Hello again. So now we're going to operate through reading from a graph. Okay, now it seems really simple, and I know it is quite simple, which is why we're going to do it, because it brings everyone up to the same stretch. And really interesting, if you can read from a graph, you can actually do this with graphs you haven't seen before, something called a Lorenz curve, which we'll be looking at shortly. Okay, so to be able to read from a graph, just as you know, all you need to do is you need to have a look at one of your axes. So you have either your x or your y axis. You will then read up from that value following the grid lines. Okay, so as you got by this dual coded piece here, you read up from your grid lines till you meet your actual graph or your curve from your data, then you read across to the other axis. That's it. But it has such an application to different types of graphs and so many different things that you can actually incorporate this throughout all of your A-level studies. Okay, so let's just make sure we've got it. Okay, so first thing we're going to look at is I have this one here. So this is a break-even graph from a business question. So there's three graphs here, and you would actually have to sit there and understand what all of them mean from just what you've been given here. So we don't have to do that because everything we're doing today and everything I'm going to show you is actually built off just numeracy. What you can do with just these numeracy skills you can take from GCSE and some of the things I'll show you. So just with just plain numeracy without incorporating any of your business understanding, we can actually use this graph to do some things. So first off, we're going to start with just reading, straight reading from a graph. Let's have a look at what would the costs of and revenues be when we actually look at 3-unit sales. So let's have a look. So we're going to go through and we're going to go right at 3. Okay, I'm going to put my ruler down here. Okay, and I'm going to read up from 3. When I hit my graph, I'm going to then leave my pencil there, and I'm going to put my ruler down again, but I'm going to put it so it's horizontally across the page. Okay, so I'm going to put it across the page here. So I put my ruler down here. Okay, and you can put a little mark. Now, once I've done that, I now have my mark there. So that means the unit sales, so at 3 units sold, I would make, now this is what the next step is. That's how much money I'd make. Okay, so this is the next bit we need to do whenever we're reading from graph. The first thing we need to do really is we need to figure out the scale. So we can tell from the bottom that each gap, if done correctly, it should be exactly the same. Each gap here represents 1 unit sold. And if we have a look at this one, that means that this gap here should represent 2,000. And every single time it's the same. Now, if we have a look here, we want to go up just less than half of that. So we want just less than half of 2,000. Just less than half of 2,000 is about 900 up. So that means that what are the costs or revenues when we have 3-unit sales? Well, that means that it's going to be 6,000, because that's this line, plus 900. So that's going to be 6,900 pounds. Okay. Now, all I'm doing there is I'm reading from the graph. Okay. So first off, you need to figure out what this is going up in here. So these are going up, and from 0 to 2,000, 2,000 to 4,000, they are going up in 2,000 increments. Okay. What does the 2,000 mean? Well, this is where it gets really nice. This is why labels are important. If we have a look at our label here, it tells us it's cost and revenues in pounds. Okay. Now, again, once I've read across from my graph, I notice that it's just less than a half. So just less than half of 2,000 is 900. So that means this would be 6,900 pounds. Let's have a look at the next question. What is the minimum number of sales unit sales needed to make £10,000. So in this case, what it's actually asking us to do is we want to find unit sales given we want to make £10,000. We're just going to use the dollar dash lines because I'm not going to go through business. I'm not going to talk. We don't need to talk about the different businesses. You will learn about that in your classes. But what is the minimum number of unit sales needed to make £10,000? So we want to go up here. We were given the information of the pounds, the £10,000. So we're going to start at this axis instead. Now, because it's on this line, and there's a line here, I don't need to put my ruler on it, so I can read it. But if you struggle with this, don't be afraid to. Okay, so this is your learning. This is your making sure you get this right. So I'm going to use my ruler. I'm going to go across this line until I hit my dash line there. Then I get my ruler and I'm going to pop it in. All right. So this is my point here. I need to make 4.5 unit sales. Now, if you think about that, can you make half of a sale? Go to somebody and be like, I kind of want to sell everything to you, but I don't want to take everything. I'll give you half of a product. I'll give you half of a can of drink. It doesn't really work. So in this case, if we go back to the question, now this is another piece which is really important. We go back to the question, what is the minimum number of sales to make £10,000? So to make £10,000 here, to have a revenue of £10,000, I need the minimum amount. If I sold 4, I would make less than £10,000. So I need to sell 5. So the answer to that question would be 5 units. Okay. Now, just reading from it is one part. That's just a further on GCSE. Now let's have a look at this next one. This one, we've got bar charts. Now, you can have a read of this here. Pause it now so you can have a read. Okay, now I'm hoping that you've paused it. You've taken the moment to read so you know what this is about. So this is the data given after 4 weeks. So this is top one is about, and it tells you here. Again, down the bottom, we've got this values here. Now, something I just missed out on, types of data. This here, like I said, you can't have 4.5 sales. So you should already be thinking, I can't have 4.5. This right here is discrete. This is discrete data that has been taken. Okay? Because you can't have 4.5, it has to be 4 or 5. Now on this one, it's a bar chart. Now bar charts are really useful, and we'll talk about this when you're expressing data, but bar charts are very good for talking about nominal data. Because even though we've labeled all these herbicides A to K, they're going to have names, and which one we put first doesn't matter. Okay, so that's why it's nominal. So this one, this is our different types of herbicide on the bottom, our dependent variables, independent variables, and on the side we have the number of weeds that were found in the field. And down the bottom we had the mass of all of those weeds. And you can see they change. So let's look at our question. Describe the differences in biomass of each of the weed plants in fields treated with herbicides G and H. So we're going to compare G and H, but we want to compare the biomass of each weed plant. Okay, so the weeds in these fields. So let's have a look. First off, if we look here, G and H, they have exactly the same number of weeds. So if they have exactly the same number, if you look down at the biomass of them, G, there's a higher mass for G than H. That means that for every one of the G, they're actually going to be heavier. Now I can get that from that information just from this table alone. That's just reading the data. Now there's more going on, but that's really what I'm doing. I'm looking at the fact of the height. So this is going to be what? This is going to be 1.55, and this is going to be 0.85. Now, where did I get those numbers from? So if I look across to here, I have a look at my scale again. My scale goes from 0 to 0.5. So that means that's 0.5 distance. I have 5 boxes. So if I divide this by 5, I should get every single box going up. That's really useful because actually you need to make sure you're using values. So you're telling marker how you're interpreting your results, that you're actually interpreting the right results. If you struggle with this, what you could do is you could do this. I could take a guess. Is it 0.2, 0.2, 0.4, 0.6, 0.81? No, it's not that. Let's try something else. Let's try what I would think. I'm going to divide this by 5. 0.1, 0.2, 0.3, 0.4, 0.5. That means each box, okay, is 0.1 going up. It's just like that. Okay, just take your time and read the scale. You do the same up the top. We have from 100 to 200 here. Doesn't matter which one you pick. It is easy to pick the bottom one, but it means there's a difference of 100. So we have 5 boxes. So that means that I need to do 100 divided by 5 to find out how many is each box going up. So I do 100 divided by 5 is going to be 20. Now, again, you don't have to do this maths. You could actually just do guess and check. I could say, is 40, 40, 80, 120. I've already gone over 100. And let's try 20. Now, I always try 20, 40, 60, 80, 100. Perfect. Okay. Read the scales. Take your time. All right. Sorry, we jumped in there. Okay. So let's look at these questions. Describe the differences. So their numbers are the same, but G has more mass. So that means that G has more biomass, or the weed plants are bigger for each one of them on average. Okay. The weed as, and I would always explain it for 2 marks as the number of plants for G and H are the same. And G has a less biomass. Last but not least, the farmers decided that K would be the best herbicide to use. Explain why the herbicide K would give the higher crop yield. So let's have a look. If we have a look here, the biomass of weeds in the field is actually less for D. So let's have a look. That can't be the reason why. But if we go to the top, the number of the weeds. So the number of the weeds, if we have a look, this is half of that first square. That means that there's about 10 weeds in this field. That's it, compared to the others, which are over 100. So therefore, it's because there's less weeds in the field. Now, you'd have to go further and you have to talk about why. Now, this is a biology question. So you'd say K because there's less weeds in the field, and then you'd go further with your biology, which could be things such as there's less competition, okay, for the actual barley. Okay, and now what I'd like you to do is I'd like you to go through and actually try. There's a couple of questions down below. I'll scroll down. Okay, there's a question here which has you comparing a bar chart for a psychology question. And here is another one, which is a geography-based question. Okay. And as you can see, there's 3 marks for these questions, but there's 1 mark purely for reading and putting the values that you have into your answer.